All right, so the next standard is to use data to describe the force of an object. So what that has meant for us is to calculate net force and missing force vectors. So let's do some remembering. What produces a change in motion? That is right, an unbalanced force. But please remember, acceleration is a change in motion. So an unbalanced force causes acceleration, and that can be either in speed or direction. So when we're calculating net force, here's a few steps. So cross off the forces that cancel out, those that are exactly the same. So make sure when you're calculating, then look at what is left over. If the net force does not equal 0, the object will accelerate in the direction of the net force. Okay, so that'll help. So let's do some practice. I'm going to flip over to my document camera. All right, so first of all, let's look at the problem here. So the first thing is to cancel out anything. So the normal force and the gravitational force are canceling each other out. So 40 and 40. Now, let's cancel out what we can here. So 200 newtons gets canceled out with 200 of the applied force newtons. Leaving 100 newtons to the right. So the net force is 100 newtons, right? If you put 100 newtons, that would be okay. I'll let that go. And didn't put 100 newtons, right? That would be fine. And the question then is it accelerating? Yes, because an unbalanced force is acting on it. And which direction? To the right. All right, let's do the next one. So what's this first step? Cross off what cancels out. Well, this 6 newtons cancels out with this 6 newtons, and this 5 newtons cancels out with that 5 newtons, leaving a net force of 0. So, is it accelerating? No, because the forces are balanced. They cancel out. Let's look at letter C. This would be a free-falling object. Only gravity is acting on it. So what's the net force? Well, nothing cancels out. There's nothing to cancel out gravity. And so the net force is 5 newtons. And is it accelerating? Most definitely it is. It's accelerating down. All right. Now this would, I was surprised, but I get it. Letter C really was one that tripped people up. But again, the reason that is because this is something that's falling. If you dropped a Chromebook, it might have a force of gravity of 5 newtons, and it's accelerating downward. Let's look at the next one. So first of all, cross off what cancels out. So this 10 newtons crosses off with this 10 newtons, and this 5 newtons cancels out 5 newtons of applied force, leaving 5 newtons of net force. Is it accelerating? Yes. In which direction? To the left. All right. Let's look at letter E. Excuse me. So first step, what cancels out? Well, 30 of this cancels out 30 of that, leaving 10 newtons still pulling down. Was it accelerating? Yes. In which direction? Down. Last but not least, let's look here. Well, first of all, before we try to do anything, let's add these up. So 2 different forces are pulling to the right, adding up to 25 newtons. Well, this 20 newtons cancels out with this 20 newtons, and this 25 newtons cancels out with this 25 newtons. So the net force is 0. Is it accelerating? No. All right. There's some more practice problems on your worksheet for this. Please go ahead and do those. If it's not making sense, let me know. Let's flip back to our PowerPoint for the next part of this standard. So sometimes a free body diagram might be given to you where some of the vectors are given and the net force is given, and what's being asked of you is to calculate what's missing. So let's go through the steps to figure this out. So first of all, you want to cross off the vectors that cancel out, just like you did before, so we can ignore them. Then the net force is, if the net force is 0, the missing vector is going to be the same as the one that is opposite to it. If the net force is not 0, then we have to do a few things. If the net force is in the direction of the missing vector is going to be that much more than the opposite one. If the net force is in the opposite direction of the missing vector is that much less than the one that's opposite. And if the net force is not in the direction of the missing vector or opposite of the missing vector, the missing vector is going to be the same as the opposite. So let's look at how this actually works in real life. So here we go. Our first one, letter A. So let's see. So the net force is 50. So again, we want to cancel out anything that cancels. 50 to the right. So we don't know C, so we can't worry about up and down yet. But we can cancel out 50 here and leaving 50 newtons to the right, which is our net force. And so the net force is in a direction that's totally different than either the missing vector or the one that's opposite to it. So we know that the missing vector has to cancel out what's there. So C is also going to be 50 newtons because these are equal and opposite, canceling each other out and not affecting the net force. So let's move down to look at B. So the first step again is to cancel out anything that's equal and opposite. So those two 100s cancel out. The net force is 0, and so A is going to be equal to the one that's present. Let's look at letter C. Now this one's a little different. So we've got 100 newtons to the left and 100 newtons to the right, and our net force is 0. What do we know about the relationship between A and B? Well, we don't know any real numbers for A and B. What we do know for A and B is that they are equal. They're equal and opposite. Okay? Why do we know that? Well, they cancel each other out because the net force is 0. Alright, so first step, let's cancel out what we've got. We've got 300 newtons to the left, 300 newtons to the right. The net force is 700 up. And if we go flip back to this, and it says, if the net force is in the direction of the missing vector is that much more than the opposite one. So the net force is in the direction of the missing vector, which means it is 700 newtons more than the opposite one. So it's 1200 newtons. And you can double check your work, because if you crossed off if you put 1200 here, well, 500 newtons of the 1200 would cancel out, leaving 700 newtons as the net. So that is correct. Let's look at the next one. So we've got 30 newtons up and some unknown amount going down. The net force, though, we do know was 100 going down. So that goes back to our, if the net force is in the direction of the missing vector, then the missing vector is that much more than the opposite one. So B is 100 more than 30, so 130 newtons is B. And is it accelerating? Most definitely, because the net force is not 0, and it's accelerating down. Okay, let's look at our last practice one here that we're going to do together. The net force is 70 newtons to the right. The two 80s will cancel each other out. Now, we haven't seen one quite like this, so we got to go back here. If the net force is in the opposite direction of the missing one, the missing vector is that much less than the opposite. So that means then that G is 70 less than 100. So 100 minus 70 equals 30 newtons. So the answer is 30 newtons. G is 30 newtons. It is accelerating, yes, because the net force does not equal 0, and it is accelerating to the right, the direction of the net force. All right, ladies and gentlemen, please do the practice on your review sheet. Turn it in to me tomorrow, and you can retest. Thanks very much.